In this lecture module, we raise the curtain on the third and final act of this particular lecture. We'll look at the three doctrines that I use to spell out logical empiricism. We'll start with the doctrine that laws are exceptionless universal axioms, and that theories are axiom systems that define the structure of a domain using a series of exceptionless universal laws. Then we'll turn to our second doctrine, the doctrine that the content of scientific theories, both the theoretical terms and the values for the variables within the laws themselves, get their meaning and their values through categorization, operationalization, and a theory of meaning. Specifically, we'll focus on the verificationist theory of meaning. We'll note that the verificationist theory of meaning not only had a positive and constructive role to play in the logical empiricist framework, but it also was weaponized against metaphysics by declaring many philosophical problems and metaphysical systems as meaningless. Finally, we'll look at the third doctrine that I want to use to understand logical empiricism, the unity of science. And specifically, we'll emphasize how the unity of science is built upon a notion of intertheoretic reduction, where this intertheoretic reduction creates a structure of science that is a nested hierarchy of axiom systems, from the special sciences like sociology, down to psychology, down to biology, molecular biology, chemistry, physics, and ultimately a reduction to the observation language. Positivism emerged in Vienna around 1929. It was in large part a reaction against the heavily a prioristic and metaphysical philosophy of the time, especially German idealists. Positivists were mostly scientists or scientifically trained philosophers. Early positivists took as their goal the application of science and logic to philosophical problems. And specifically, early positivists had three general theses and were primarily located in two major areas. There was the Vienna Circle and the Berlin Circle. Our first thesis is that scientific theories are exceptionless universal statements that are gathered together into axiom systems which collect the laws of a particular domain and organize them. We see this structure as an explicit metaphor, drawing a strong line between Euclid's axiom system, the attempts to axiomatize mathematics, and a structure for science itself. We can see now that promissory note that I said way back when we were discussing Euclid during the Hellenistic period lecture, that it shapes everything that goes after it to some important degree or another. In this case, I'll talk about it in terms of the deductive nomological theory of explanation that's offered up by Carl Hempel and Paul Oppenheim, and in particular I'll focus on the view as they articulate it in their 1948 paper. So Paul Oppenheim was a German chemist, and together he wrote this paper with Carl Hempel in which they outline an account of explanation by subsumption. The gist of the paper is that explanation is the same as prediction, which simply is a matter of deriving the thing to be predicted using your laws together with a statement of the antecedent conditions, the values for the variables in that law for that particular application of those laws. In the deductive nomological model, laws function as axioms and theories as axiom systems. For example, suppose we want to explain or predict the periodicity of a pendulum as being 2.006 seconds. We have our ideal pendulum law, and we have a value for gravitational acceleration and a value for L, the length of the arm. We then, using our deductive nomological model, plug those values into our law, the ideal pendulum law, and deduce our explanation or prediction of the pendulum periodicity based on those initial values and the universal exceptionalist law that we use to calculate the explanans or thing to be explained or the prediction from our law and initial conditions. Thus, on the deductive nomological model, predictions and explanations are deduced from axiom systems of domain-specific laws using current values for the variables of those laws. The values, as well as the meaning of the terms, both the theoretical terms and the variable terms, comes from our second doctrine.